Hi viewers, today I have chosen the most important topic, that is quadratic equation. It is the chapter 4 in the textbook of class 10th. It's very important for every child to understand the basics behind the equation, because right from 8th class you will see the chapters on equations. In 8th class there you have a linear equation in one variable, and in 9th class you have linear equation in two variables. In 10th class we have pair of linear equations in two variables, and also the quadratic equation. Here we will try to understand the equation in detail. Before defining the equation, I think we should have proper knowledge of algebraic expressions. So I will write here the algebraic expression. You might have gone through the algebraic expression. It is defined as the combination of constants and variables by arithmetic operations. So here try to understand. We are going to understand the equation, basically what is the equation. Then we will understand the quadratic equation. Before understanding the equation, let's have a brief look on the algebraic expressions. You might have gone through this algebraic expression in your previous classes. Many of you are well aware about the algebraic expressions, so I have decided to give brief introduction about the algebraic expression. The constants and the variables by arithmetic operations makes the algebraic expression. So here the thing is constants and variables and arithmetic operations. Three things are here discussed in the definition of the algebraic expression. We will try to understand all the three things. First, arithmetic operations. We have four fundamental arithmetic operations, or we can say basic operations, that is addition, subtraction, multiplication and division. These are the four fundamental operations. Now coming to the constants and variables. What are the constants and variables? We would like to understand these two things in detail. I will write here the constant, and here I will write the variable. Constants and variables. What are constants? These are the fixed values in expressions. These are the fixed values in the expressions. They never change, they remain unchanged. And one more thing, all the numbers, especially the real numbers, when you will see the numbers like 1, 2, 3, etc., -1, -2, -3, 1/2, 1.1, √3, √2, whatever may be, in any expression, you have to understand that time they are the constants. And now coming to the variables. What are the variables? These are unknown values. Their value varies. They will not remain the same. And all the English alphabets, whenever you will see the English alphabets like A, B, C, X, Y, Z, any of the alphabet in any expression, you have to remember that is the variable. So I will give you the example here once again. I will write x plus 1. What is this x plus 1? This is the combination of constant and variable, because as I earlier told you, in any expression, when you will see any number, any real number, you should understand that is the constant. So here it is the constant. And when you will see any English alphabet, that is the variable. Its value, we don't know its value. Its value can be any one of the real numbers like 1, 2, 1/2, 3, 4, 5, 6, 7, 8. Any of the value we can have here for this x. So this is the variable and this is the constant. Combination of constant and variable. Here the arithmetic operation is addition. It forms the algebraic expression. Similarly, I can write a plus b plus c. Is this an algebraic expression? Yes, this is the combination of constant and variable. How? Here A is the variable, B is the variable, C is the variable. As I earlier told you that any English alphabet in any expression, that is the variable. So now here you will have a little bit confusion. Here no number is seen here. Actually you need to understand that whenever we will write any variable like x, its coefficient, the numerical value with it is 1. We can also write it 1 is to x. So here 1 is the constant and x is the variable. So we can also say that this A contains 1 here as its coefficient. So this is the combination of constant and variable, that is algebraic expression. So what I need to understand from this, from algebraic expression, what was the need to understand for the equation? Actually I need to understand here the constants and the variables. So in any expression you should remember this thing. Whenever you will see the numbers, any number among the real numbers, that you should understand that is the constant. And in any expression, when you will see the variables like A, B, C, D, any English alphabets, you should understand that is the variable. Now I will give you one more example. If I will write here P plus 3, you should understand this is the variable and this is the constant. Now coming to our main topic, that is the equation. Our topic is quadratic equation, but first we will try to understand what is the equation. A very common and simple definition of the equation is, it is defined as the statement of equality containing one or more variables. A very common definition is this: statement of equality containing one or more variables. Try to understand the definition of the equation. Statement of equality. First we will try to understand what is this statement of equality. If I will write here 2 into 3 is equal to 6, everybody knows 2 3s are 6. This equality sign is here. It makes the whole statement as the statement of equality. Similarly, if I will write 1 plus 3 equals to 4, this is the statement of equality. If I will write 5 divided by 5 is equal to 1, this makes it the statement of equality. So this was about the statement of equality. Now if this statement of equality contains one or more variable, at least we should have only one variable. For example, I will write here x plus 3 is equal to 4. See here, this is the statement of equality, but this contains one variable. It means first it is the statement of equality and now variable is also present. Now according to the definition of the equation, statement of equality containing one or more variables, this is the equation. This is the equation. Similarly, I can write x plus y equals to 0. See here at least we should have one variable and should be the statement of equality. Variable and equality sign. So this is also the equation. So briefly I will conclude the equation. And in an equation always there will be the equality sign. There will be two expressions. One is the LHS and second one is RHS. And at least there should be one variable. At least there will be one variable. Also I can give the example. If I have x square plus 1 is equal to 0, this is also the equation. If I have a plus b plus c equals to 0, that's also the equation, because statement of equality and variable. So in an equation we have equality sign, we have LHS, we have RHS, two expressions. Now this we need to understand the LHS and RHS. LHS, I hope that you will understand it very clearly. This is left hand side. The left hand side of the equality sign is known as LHS. The right hand side, its short form is RHS. So LHS and RHS. Now we can say again one more definition. We can define the equation. It is an algebraic statement. It may be defined as an algebraic statement in which two expressions are separated by an equality sign. So you need to understand this. So how we can define? It's an algebraic statement. Algebraic statement means it will be statement containing a variable in which two expressions means LHS and RHS are separated by an equality sign. This was about the equation. Now we will try to understand the solution of equation. What is the solution of equation? You have seen the questions like solve the given equation. That means to find the solution of the equation. See here, our question is, what is the solution of equation? This is the question. What is the solution of equation? If I will write here a simple equation, x plus 1 is equal to 0. See here, it means this LHS is equal to RHS. X has some value. If I will put x is equal to 1, on that time or LHS, my LHS in this equation is x plus 1 will be equal to, in place of x I have to put 1. 1 plus 1 is equal to 2. So LHS becomes equal to 2 on placing x is equal to 1 in LHS, which is not equal to RHS. Try to understand this. If I will put x is equal to minus 1, my LHS in the given equation is x plus 1. In place of x I will write minus 1, then plus 1 is equal to 0. This time LHS is equal to 0. That is also my RHS. So LHS becomes equal to RHS. See here, when I substituted x is equal to 1, when I substituted x is equal to 1, on that time my LHS is not equal to RHS. The equation does not get satisfied on putting x is equal to 1. And when I put x is equal to minus 1, on that time LHS is equal to RHS. That means this equation gets satisfied on the value of x is equal to minus 1. So I can write x is equal to minus 1 is the solution of equation. So you should understand this thing. What is the solution of the equation? It is the value of the variable in the equation. It is the value of the variable in the equation. I can write here, it is the value of variable in an equation that satisfies the equation. Means when we put this value instead of this variable in given equation, our LHS will become equal to RHS, because in equation there will be LHS and RHS. So value of the variable that satisfies the equation is the solution of the equation. Sometimes we have equations like this, x plus y is equal to 0. This is linear equation in two variable. This is linear equation in one variable. We will discuss later these types of equations. Here the solution will be the value of the variables, because here are two variables. It means at the same time two numbers will be the solution. If x is equal to 1, on that time y will be equal to minus 1. So x is equal to 1, y is equal to minus 1 will be the solution of the equation. Here only one variable was there, so here only one number will be the solution of the equation. But here two variables are there, so here two numbers will be the solution of the equation. This was about little bit about the solution of the equation. Later when we will discuss and solve the exercise, on that time we will once again try to understand deeply the solution of the equation. Now we will try to understand few types of the equation. We have, starting in the 8th class, we have read it, linear equation in one variable. We will try to understand what is this linear equation in one variable. I will give you some examples first. If I will write here x plus 1 is equal to 0, I will write x plus y is equal to 0. I will write x square plus 1 is equal to 0. I will write x cube plus 1 is equal to 0. See here, these all are the equations. But see here in this equation, there is one variable and power of variable is 1. There are two variables and power of each variable is 1. And there is only one variable but power of variable is 2, and here is one variable and power of variable is 3. Try to understand these. What is the difference between these equations? One variable power is 1, two variables each having the power 1. Here in this equation one variable power is 2, here one variable and power is 3. Try to understand. These two equations, they are the linear equations. They are the linear equations. Why they are linear equations? Because in each term the power of variable is 1. In each term power of variable is 1. It means they are the linear equations. So try to understand. Linear equation is that equation in which the power of variable is 1. Linear equation. Those equations in which power of variable or variables in each term is 1. Those equations are known as linear equations. But see here is only the one variable and here are two variables. It means this equation is linear equation in one variable. This equation is linear equation in two variables. So how we can define the linear equation in one variable? We can generally define it an equation in the form of ax plus b is equal to 0. A should not be equal to 0, where a, b are real numbers. So we can define the linear equation in one variable as an equation in the form of ax plus b equals to 0. A is not equal to 0, where a, b are real numbers. All the equations which are in this form, they are the linear equation in one variables. This form is also called the standard or general form of linear equation in one variable. See here, if I will write 2x plus 1 is equal to 0. Try to understand here. Here this equation is in the form of ax plus b is equal to 0, because here this a is the coefficient of x and 2 is here the coefficient of x and b is here the 1 in this equation. So I can write, if I compare these two equations, I can write a is equal to 2, b is equal to 1. Since here is only the one variable in the equation, there must be only one solution. Now see here, I have 2x plus 1 is equal to 0. If I will put x is equal to minus 1 by 2, see here, so 2 into minus 1 by 2 plus 1, I am talking about the LHS of the equation. 2 cancel, minus 1 plus 1 is equal to 0, which is equal to RHS. So I can write x is equal to minus 1 by 2 is the solution of the equation. No value other than this can be the solution of the equation. So linear equation in one variable has only one solution. This is the basic You might have gone through these equations in 8th class, also in the 9th class. Now our main topic is the quadratic equation, but I have decided to give you little information about the basics. Second, we have linear equation in two variables. Linear equation in two variables. An equation in the form of ax plus by plus c is equal to 0, where a, b should not be equal to 0. A, b, c are real numbers. This is the linear equation in two variables. It means any equation in this form, ax plus by plus c is equal to 0, will be known as the linear equation in two variables. Here a is the coefficient of x and b is the coefficient of y. C is here the constant term, and this is RHS. And this equation, linear equation in two variables, have infinitely many solutions. Infinitely many solutions. Infinitely many solutions. I will give you the example. If I have x plus y is equal to 0, see here, for every value of x there will be corresponding value of y. If x is equal to 1, on that time, see here, if I will substitute here in this equation 1 plus y is equal to 0, it implies y is equal to minus 1. So one solution will be x is equal to 1, y is equal to minus 1. This will be the one solution. Similarly, if x is equal to 2, y will be that times minus 2. So for every value of x there will be corresponding value of y. So a linear equation in two variable have infinitely many solutions. This was about the linear equation in two variables. Now we will come to our main topic, that is the chapter 4 in our textbook, that's quadratic equation. Now we will see the quadratic equation. It can be defined an equation in the form of ax square plus bx plus c equal to 0. A is not equal to 0, where a, b, c are real numbers, is known as quadratic equation. Now see here, the general and the standard form of the quadratic equation is ax square plus bx plus c. Any equation that is in this form, that is known as the quadratic equation. For example, I will write here 2x square plus 3x plus 1 is equal to 0. If I will compare this equation with this, ax square plus bx plus c is equal to 0. Now see, x square, here a is the coefficient of x square, so here 2 is the coefficient of x square, so I can write a is here 2. B is the coefficient of x, so here 3 is the coefficient of x, I can write b is equal to 3. And c is here the constant term, and here 1 is the constant term, I can write c is equal to 1. So I can write, yes, this is the quadratic equation. Second example I can give you, if I write x square plus 1 is equal to 0. Now see here, if I will compare this equation with the standard form, that's ax square plus bx plus c is equal to 0. Coefficient of x square is a. Here coefficient of x square, it is nothing is written here, so coefficient of x square is 1, so I can write a is equal to 1. Coefficient of x is here b, but here the term with x is not present, so I can write b is equal to 0. So xc constant term is 1, here c is equal to 1. So yes, this is the quadratic equation. Now I will give one more example. If I will write x plus 4 is equal to 0. Now see here, if I will compare this with ax square plus bx plus c is equal to 0. See here, coefficient of x square is a. Here the term with x square is not present, so I can write a is equal to 0, b is equal to coefficient of x is here 1 and c is here 4. So here a is equal to 0. It means the term containing x square is not present. We have here in the general form a should not be equal to 0. So here a is the 0. It means this is not a quadratic equation. A should not be equal to 0. So we can conclude that in a quadratic equation the term containing x square should be present. Whether bx is present, c is present or not, that doesn't matter. See here, if I will write here x square minus 1 is equal to 0, y square minus plus 2 is equal to 0, p square plus 1 is equal to 0. X can be any English alphabet. Whether it generally we are taking the x, but x can be any alphabet. Here x square, y square plus 2, p square plus, in every quadratic, these all are quadratic equations. Why? Because only we need to see first the equation equal to the statement of equality variable, then we need to see there should be present the term ax square. If ax square is not present, it means the term containing x square is not present. That is not the quadratic equation. So I can write for an quadratic equation, the term containing x square should be present. Otherwise the equation is not the quadratic equation. Now see the exercise 4.1. The question 1 is check whether the following are quadratic equations. So we have different questions. We need to understand, we need to see whether the following these equations are quadratic equations or not. For to be a quadratic equation, we should understand they should be in the form of ax square plus bx plus c is equal to 0, and at least it should contain the term ax square. If the term containing ax square is missing, it means that this is not the quadratic equation. See how we will solve this. First we will simplify it. I will write once again here x plus 1 whole square is equal to 2 into x minus 3. Here we will use the formula a plus b whole square. Which formula we will use? A plus b whole square is equal to a square plus 2ab plus b square. So x plus 1 whole square, we can write implies a square, in place of a it's x, so I can write x square plus 2, what is a, in place of a x, in place of b 1 plus 1 square is equal to 2 into x is 2x, 2 into minus 3 is equal to minus 6. So I can write this implies x square plus 2 into x into 1. 2 into 1 is 2, it's 2x plus 1 is equal to 2x minus 6. Now I can write it implies x square plus 2x plus 1. I will transpose these terms to the left hand side. This will be minus 2x, this will be plus 6 is equal to 0. So I can write here x square is only the one term, I can write x square. So this is plus 2x, this is minus 2x, they may cancel each other. Plus 1 plus 6, it will become plus 7 is equal to 0. Now see, on comparing with this ax square plus bx plus c is equal to 0, we will see here a is 1, b is 0, c is 7. Only here a should not be equal to 0. If a is 0, that means the term containing x square is 0, is not present, then we can say that it is not the quadratic equation. Whenever you will see the power of x2, it means the term containing ax square is present, it means it is the quadratic equation. We can write yes, it is in the form of ax square plus bx plus c is equal to 0. A is not equal to 0. Therefore it's a quadratic equation. It is a quadratic equation. See the third part. X minus 1 x plus 1 equals to x minus 1 x plus 3. We need to check whether this is a quadratic equation or not. First we will do the simplification. It implies we should multiply this x to the whole. I can write x into x plus 1, then with minus 2. Minus 2 into x plus 1 is equal to, then with this x we will multiply this whole expression, x into x plus 3. Then with this minus 1 we will multiply this whole expression, minus 1 into x plus 3. See here, it implies x into x is x square plus x into x 1 is x, minus 2 into x is minus 2x, minus plus minus 2 1 is 2, is equal to x into x is x square plus x into 3 is 3x, minus 1 into x is minus x, minus into plus is minus 3. So I can write here, this is x square minus 2x plus x, here is minus x minus 2, is equal to, this is x square 3x minus x plus 2x minus 3. Now I will do the transposition. This x square minus x minus 2, this x square will I will transpose it here in the left hand side. This is minus x square minus 2x, the signs will change, this is plus 3 is equal to 0. Minus x, this x square I transpose here, so its sign will change. Here it's plus, it will be here minus. It's plus, it will be here minus. It is minus, it will be here plus. Now I will check the same terms, similar terms. This is x square plus x square, this is minus x square, they may cancel. Minus x minus 2x minus 3x minus 2 plus 3, so plus 1 is equal to 0. I can also write, I can also multiply it with the minus, because it's not good to keep a minus term at first. So I can multiply it with minus. Minus 3x plus 1 is equal to minus 0. I multiplied minus both sides. It will become 3x minus 1 is equal to 0. Now see here. Here the term with x square is missing. It means a is here the 0. So it's not a quadratic equation. It's not a quadratic equation. Why it's not a quadratic equation? Because here the term containing x square is not here. Term containing x square is not present. Here a is equal to 0. So it is not a quadratic equation. Quadratic equation. Thanks for watching.